Hello, I think I'm live. Awesome. Just 1 minute early, so I'm going to wait until 2 o'clock exactly before we get started. But I guess a few people are here. Okay, cool. Can everyone hear me okay? Can you see me? Okay, cool. Awesome. Send me some messages in the chat box if you have any questions. And I guess it's now 3 o'clock exactly in Norway, 2 o'clock in the UK. So welcome to another Earth Live lesson by Lizzie Daly. Also, thank you so much for tuning in. And thank you, Lizzie, for inviting me on. If you haven't watched any of Lizzie Daly's other videos, they're an incredible series, just 20 minutes, really good for kids if you're homeschooling and also adults. I've been learning a lot from great scientists, conservationists, and filmmakers around the world. My name is Clare Andvik, and I live in Norway, but I'm from Britain originally, as you can probably hear. And I study pollution in whales in Norway, and more specifically killer whales or orcas. I'm probably going to move between those two words quite often. So I moved to Norway about 6 years ago. I quit my job as an accountant in London because I wasn't really happy in my job, and I was like, what did I always want to do since I was a kid? And that was study whales. So I quit my job, I moved to Norway, I studied again right from scratch, studied biology, and now I'm a marine ecotoxicologist, which means I look at pollution in marine wildlife, and I specialize in whales. So I work as a research assistant at the University of Oslo, and I also work with the organization Norwegian Orca Survey, which study orcas in Norway. And I've been working with Norwegian Orca Survey since about 2016 and had some great trips out to see orcas. The picture on the little Twitter, that was my first ever encounter with orcas up in northern Norway in 2016. Beautiful summer day, water was completely flat, and then orcas were coming up right next to the boat. So in this live lesson, I'm going to be talking a little bit about what could threaten orcas, so pollution. Because orcas, they are right at the top of the food chain. And when we say that, that means that they don't have any other predators. So there's no other animals that are wanting to eat and kill orcas. But they do face a huge threat from pollution because they are at the top of this food chain. And I'm going to be talking through a little bit of why they are especially at risk, how this pollution comes into the environment, how it comes up into orcas, and what we can do to try and make this better and to make a difference. So I'm going to begin by drawing attention to this little poster behind me, if you can see it. So I'm going to be talking through bioaccumulation and biomagnification, and I'm going to be illustrating this a little bit later as well. So here we have a very simple food chain. So we have the plankton here at the bottom, we have fish, and then we have seals, and then we have polar bears. So the polar bear eats the seal eats the fish, and the fish eat the plankton. And these little red dots, they are representing pollution in the environment. So these red dots, this pollution, we're mainly talking about chemicals in my work, so not so much plastics, but plastics are also a big issue. So they get into the environment from human activity. So it's stuff that us humans are releasing into the environment. So some examples are pesticides. If we use pesticides on our crops, and these can run off into the marine environment. We can also use lots of different chemicals in industry. So when we're trying to make electronics, for example, we use a lot of different chemicals. And another example is when we want to make material, and like sofas and beds, for example, we don't want them to burn very easily because we don't really want everything to catch fire that easily. So we put a chemical on them called brominated flame retardant, or at least we used to, and that protected these things from getting caught on fire. But they can also cause big issues. So when we throw away these objects, these chemicals start to leach out and they come into the environment. I've just got a question coming from Mike. You're demonstrating outside the Brighton Centre. Yeah, so voted to ban whaling. So whaling, unfortunately, is still occurring in Norway. They hunt the minke whale, But it's not very many Norwegians really eat minke whale, and I'm people generally not really sure if it's going to be continuing. They also do hunt whales still in Iceland and in Japan, but hopefully we can all work together to prove that whale watching is a lot better alternative to whale hunting. So yeah, but good question. Mainly, in most countries, whales are protected. Yeah, so this pollution from human activity, pesticides and like industry and loads of different places, they get into the environment. And one feature of these different chemicals is that there's something called lipophilic. And that is a fancy word for meaning that they love fat. So they prefer to be in an organism than in the water. So they're floating around in the water. They're kind of almost attracted to organisms. So they get into this plankton, and then the fish eat the plankton. The fish needs to eat a lot of plankton in order to get enough energy. And then the seal eats the fish, and the polar bear eats the seal. And the polar bear is right at the top and gets a huge amount of this pollution. It's quite hard to see on this poster. So I've got a little thing which I'm going to try and show you to explain this concept a little bit better. So I'm going to bring out all my glasses, and I'm going to use Skittles to try and explain bioaccumulation. I'm quite curious to see how this is going to work on a live video. All right, let's see. Let's see how this goes. I'm going to move the video back. I'm going to crouch down a little bit. Okay, right. Are you ready for this? This is a little bit more fun in person because you actually get to eat the Skittles as well. But I will eat the Skittles afterwards, so don't worry, they will not be put to waste. So here, right at the bottom of the food chain, here we have plankton, right? And in plankton, we have some green Skittles, and that represents energy. And that's what organisms want, because they need energy in order to move around and to feed and to reproduce and do all their things, swimming, everything. And the little red dots are the pollution, so the little chemical pollution. And so I have at the bottom here, I have 6 plankton. Here we are. And the next layer on the food chain, I have some fish. So I've got herring, which are very, very abundant in Norway. And 3 herring. And at the top here, I've got a orca. So the orca is going to be eating the herring are going to be eating the plankton. And we're going to see how all of these pollution, they come up into the killer whale and get into really high levels in the orca. I also have this little thing here, a little fire, and that's to represent burning of energy. So every layer, we end up burning energy because we need to have enough energy to swim around and to live and reproduce and do all these other things. Okay, let's see how this works. And please ask any questions if you can't see anything properly or you don't understand what I'm going on about. Okay, so we'll start with the plankton. I'm going to leave one plankton to the side so you can kind of you can see at the end the difference. Okay, here we go. So the plankton is going to be eaten by the fish. So I'm going to bring this over. I'm going to take some of these green ones out to represent some of the energy getting burnt by the plankton. Because plankton, they also need to reproduce and swim around. Play with their friends. No, that's not really funny, but I mean, it's actually true that plankton, I've got a friend in my research group who was studying plankton, and they actually have different personalities. So plankton aren't just plankton, they are very, it's actually very interesting that they, okay. So this is also something that you can do at home if you want to explain to your parents or to a friend what about bioaccumulation, how it all works. Great excuse to say that I need some Skittles because everyone needs an excuse to buy some Skittles. Yeah, plankton personalities, it's actually true. And it's actually means that they respond to this pollution differently. So based on how they, based on their personalities, some of them like to swim around a bit more, some of them don't, some of them like a bit more social. So it's makes it more difficult to predict how this pollution is going to act. Okay, so now we've got all the plankton has been eaten by all the herring. Okay, and now the next thing that comes along is the orca. Orca is going to eat these 3 herring. Of course, they're going to eat a lot more than 3 herring in real life, but you get the idea. I hope you get the idea. We'll see how this goes. So also the herring are using energy as they're swimming around trying to not be eaten by the orcas. So we're going to put some of that into the, oh gosh, okay, tools are going everywhere. Not seeing head. All right, I'm still here. So the orca is eating the herring, and orca in Norway, they actually have a really awesome method to hunt herring. So they work together and get the herring in a really, really tight ball, and then they slap the herring ball with their tails, and that basically stuns all the herring, and it's a lot easier for the orcas than to eat the herring. So it's a very specialized way of hunting. Do plankton chat with each other? I really don't know. I haven't really studied plankton so much, but they very well could do. Right, so here we've got it over here, and so the point here is that you see that the red pollution, that doesn't get burnt away. It's really, really persistent, and it goes up on each trophic level and goes into quite high levels in the orca, whereas the energy gets burned up on each level. And if we compare to our first plankton, you should hopefully see that it's a lot higher number of red pollution in the orca than in the plankton. Okay, so what is also very exciting about orcas in Norway, and it's what I've been studying quite a lot, is that some orcas in Norway, rather than eating herring, they seem to enjoy eating seals. So that means we have actually an extra trophic level, So I'm going to move the orca onto this huge cluster here. Oh gosh, enough space in here. Move some of these guys out of the way. And have the seals like this, like that. So you can hopefully see that if we have orcas that are eating seals, this is how the orca was before. But if an orca is eating a seal instead, we have an extra trophic level. And that means seals are also, okay, skittles are going everywhere. And seals are also using energy to swim around and reproduce and have babies. And so we have the skittles going over into, okay, yeah, I'm losing. Right, I'm going to have a little hunt for some skittles later on the floor. So there we are. So this is a huge part of my research. You can see that this orca here, I should have had one to compare it to, but this is a lot of red skittles, which means a lot of pollution. So the orcas eating the seals have much higher levels of pollution than the orcas who are just eating fish. And that's because we have this extra trophic level, and it ends up being in much higher levels than that plankton. So why does this matter? Okay, I'm bring this back up here. Okay, so why is this important? Why does it really matter? Well, unfortunately, these pollutions can cause really nasty health effects in orcas and in top animals. So it can interact with the immune system. So that means that they're not able to deal with illness or virus as well. They're not as able to fight off that. It also affects their reproductive system. So it means that they aren't able to reproduce as well. And it's loads of other health effects. And what's also quite sad is that when the orcas have a baby, these little red contaminants, they get passed over into the baby because, if you remember, they are lipophilic, which means they like being in fat, and there are very few things as fatty as killer whale milk. Okay, I've got a couple of questions. Great, I'm glad you guys like it. Question from Dan: are orcas seen in Sharboy thought to move further north anytime soon? It's a great question, and I wish I knew the answer. If we knew exactly where the orcas are going to be this winter, it would make our lives a little bit easier. So orcas in Norway, they've been seen around this area called Sharboy, which is quite far north, and the orcas follow the herring. So the herring, some years they were based around Tromsø, which was very easy for people to get to. Sharboy is a bit more difficult, a bit further north. We really don't know where the orcas are going to turn up next year. It depends where the herring end up moving into the fjords, and that can be very unpredictable. We're still trying to figure out why the herring go to where they go. So at the moment, I think Charvo is still a good bet, but we'll have to wait what happens. It's good if you plan to come to Norway to have plans a little bit flexible, because you're never really sure where they're going to turn up. But if you get to Tromsø, it's normally quite easy to travel from there. Okay, I've only got 5 minutes. No, how much time have I got left? 5 minutes left. Time is flying. I'm just going to show you guys something very quickly. This is a killer whale tooth. So you can see it's quite pointy, so they can grip onto fish and things. And what's very interesting on this, I don't know if you can see, there are these different layers. You can see these little lines, and those are growth layers. And we can use that to find out how old a killer whale is, counting these growth layers, because they get a new layer each time they grow or get older. So you can estimate their age from these growth layers. And what you can also do is you can take a little bit of a sample, a little tiny bit of tooth from each of these layers, and you can, in the lab, you can look at the mercury levels, for example, so you can see how the pollution levels have changed throughout their lifetime. And we can also do a clever analysis called stable isotope analysis. And that basically means that we can find out what they are eating or what kind of trophic level they've been eating at, so fish or seals. So we can see whether the orcas have changed from eating seals to fish throughout their lifetime. And we've got some samples now from stranded killer whales. We can compare these to whales' teeth from whales from the 1970s. And in the 1970s, the herring stock in Norway, it just collapsed. So there were very, very few herring left. And our hypothesis is maybe orcas in Norway started eating seals around about this time because there weren't really that much herring to eat. So very cool. We're looking at a way to compare to see if the orcas in the 1970s were just eating fish and if the orcas today are eating more seals. And then we can understand a little bit more about why these orcas are eating seals, and if it's in response to herring stocks, for example, we can start to try and predict this. Because if you can see that it's very, very important it's very huge health implications for the orcas eating seals and the orcas eating fish. So very interesting. Anything we can do? Yes, a great question. That is what I was going to try and get onto. So the number one thing that you can do at home is to recycle and put your waste in the right areas, because quite a lot of pollution that I've been looking at the moment, it has been banned for quite a long time, but it's still in the environment. But there is a lot of new chemicals out there, which we're only just finding out that could be harmful. So my advice is to, for example, if you have batteries, electrical waste, please put it in the proper recycling area. Deliver your old phone back to your shop. Do not put it in the normal waste, because when those batteries or phones or electronics are burnt, that can release some of these chemicals and it can get into the orcas. Or if they go into landfill, then it can leach out into the environment. Another thing you can do is to spread the word about how it's important to protect orcas and their environment, because this pollution, it becomes more and more harmful if they are starving. Because when they're starving, all of these pollutions that are in the blubber, in the fatty blubber, that gets into the bloodstream. And that's when it really starts causing effects. Whereas if they have enough fish, if they have enough food to eat, those pollution levels are largely immobile and won't really do so much harm. It's when they starve. Another thing you can do is to study biology. You can become a toxicologist, and we are working to find out the effects of other chemicals and trying to find out how they can harm orcas and what we can do to help them. So I would just like to say, just at the end here, that we are doing a great job at helping we're doing a great job at getting down the levels of pollution in the environment. There is still a lot of work to do, but just an example, PCBs, it's a very nasty chemical that was banned in the 1970s. But the fact that it was banned is really incredible, because you basically got all countries in the whole world to say, we need to stop producing this and we need to stop making this chemical. And they all agreed, and it's not being produced or made anymore. It's still in the environment causing harm, but the levels are going down. So if we work together and communicate, we can make a difference, and we can get these nasty chemicals out of the environment. Okay, I think that is about time. Is there any final questions? If not, I would just like to say that it will be another live lesson tomorrow, and it's going to be continuing until the end of May, I believe. And all of the lessons are on YouTube, on Lizzie Daily YouTube, so you can watch back and find out more and listen back to all the videos. If you have any more questions for me, I've got my Twitter in the little description. There's also a Twitter for the research group that I'm part of. We study pollution in loads of different animals, from plankton. We've got people studying it in plankton. We've got people studying it in bumblebees, like the effect of pesticides in bumblebees, fish, all the way right up to orcas. So if you're interested in pollution and toxicology, check that out. And also Norwegian Orca Survey. Yeah, they've got a lot of really beautiful pictures and videos. They're on Blue Planet too. So brilliant. Do you have a favorite orca? Oi, I don't have I think my favorite orca is, so in the Twitter, there's a picture of the orca like doing a fly hop, so like hopping its head up. That is number 348, I believe. So we need to come up with a name for him. I say he's my favorite because he was the first one I saw, and he jumped around and did some great stuff. How's it affecting the orca population? It's a really good question. That's what we're still trying to figure out. So we've always thought that killer whales, orcas in Norway, were just eating fish. So we thought the population was pretty okay and was going to be fine in the future. The fact that some are eating seals, that can affect some of our predictions. But generally, orcas in Norway, they seem to be doing okay. They seem to be quite fat. They're having babies, so it's really good. Orcas in other areas of the world, for example, the southern residents in Canada and the Gibraltar population, they're not doing quite as well. Also the UK population. I remember if you heard about Lulu, orca from Scotland, that had a lot of pollution in her tissues. So it's causing a big issue, but there is still hope. Okay, this has gone really quickly. I think I need to sign off now. Thank you all so much for tuning in, and thanks for all your questions. And if you have any more questions, just let me know. I'll be happy to answer any more questions on Twitter or through Lizzie or however. But yeah, tune in tomorrow for another live session. And thank you all for tuning in. Have a great Sunday. Bye.